Hey guys, here are your 6.7 day 2 notes. So on the first day, we were solving radical equations. We are still going to solve radical equations, except you might not see a radical in the problem right from the start. But I need you to remember that fractional exponents turned into radicals with a root and a power. So you'll see that we are still solving radical equations. So I could put a little reminder here. Remember, rational or fractional exponents turn into a radical with a root and a power. So if you saw this expression, yes, you don't see a radical, but remember, he turns into a radical with a root and a power. So this technically is a radical in disguise. You don't see the radical right away, but he does turn into a radical with a root and a power. Therefore, fractional exponents are radicals in disguise. This is going to turn into some radical problem, all right? And the way we were solving radical equations, we get rid of radicals in an equation by using powers and exponents. So when we solve equations that have stuff like this in it, we're still going to use powers because he is a radical in disguise. So to solve equations with fractional exponents, we still use powers and exponents. And a little bit of a spoiler, what we're really going to use is we're going to use reciprocal powers to solve equations with exponents like this, okay? So watch this. If I asked you guys to simplify these expressions, right? If I said take x to the 1/4 and raise it to another power of 3/2. Well, we use our exponent rules. Power to power, what do? We multiply exponents. And that's going to become x to the, multiplying exponents is the easiest one, right? Even multiplying fractions. Multiply the top, multiply the bottom. 1 times 3 is 3 over 4 times 2 is 8, and then you would reduce it if it did. So this becomes x to the 3/8 power. Beautiful, right? Okay, well watch this. Watch what happens when you take an exponent and you raise it to his reciprocal, right? The same fraction but flipped over. All right, so if you have x to the 2/3 raised to another power of 3/2, you have to multiply your exponents, which is going to become x to the, 2 times 3 on top is 6 over 3 times 2 on bottom is 6. But guys, what's 6 divided by 6? It's 1. It becomes x to the first, which is just x. And when we're solving an equation, that's going to be our goal. Our goal is going to be to get just x. So when you multiply any fraction by his reciprocal, they actually end up canceling out. The 2 on top and the 2 on bottom, they cancel to 1. The 3 on top and the 3 on bottom, they cancel to 1. And they literally just become 1, okay? So that's going to help us a lot. If you want to get rid of a fractional exponent, then raise it to its reciprocal power. Let me show you that again. So if you have x to the 5/6 raised to his reciprocal 6 over 5, watch what this becomes. This is going to become x to the 5 times 6 on top is 30 over 6 times 5 on bottom is 30. And what's 30 divided by 30? It's 1. And who's x to the first? It's x. So again, essentially what's happening is the 6's are canceling to 1, because when you multiply by 6 and divide by 6, they cancel. When you multiply by 5 and divide by 5, they'll cancel to 1. So they're canceling each other out and leaving you with just x. So if you have x to the 1/4 raised to his reciprocal, which is 4 over 1, guess what's going to happen? The 4's are going to cancel, the 1's are going to cancel, and you're going to be left with just x. And that's what we need to happen when we're solving an equation. We need to get to just x. So if we're going to solve equations with fractional exponents, then we're going to end up raising both sides to its reciprocal, and that's going to get rid of those exponents for us. All right, so I've written down some solving steps for you. The first thing you want to do is just like before. Your first step was to get the radical alone, right? Well, now your step is going to be get whatever the fractional exponent is on alone. Whoever that fractional exponent is on, whether it's on just x or whether it's on a set of parentheses, you want to get that by itself. Okay, then you want to get rid of that exponent. So you're going to raise both sides of the equation to the reciprocal power. So whatever fractional exponent is there, you're going to raise it to the reciprocal, flip that fraction over, okay? And then you'll be able to solve for x. Okay, so look at this. Our job is to solve this equation for x, right? He's right there. We have to get x completely by itself. All right, so our first goal is to notice who is this fractional exponent on? Is it on x and the 3 or just x? You should know that it's on just x. If they wanted it on the x and the 3, they would have had to use parentheses, right? So right now, the 1/3 is only on x. So our job is to get x to the 1/3 by itself. This 3 and this -5, they got to go to the other side. All right, so who do we always move away from x first? The one that's attached or the one that's not attached? The one that's not attached, right? So we're going to add 5 to both sides. And we're going to get 3 times x to the 1/3 equals 10 plus 5 is 15. Okay, well, like we said, the 1/3 is only on x. We got to get x to the 1/3 by itself. So this 3 has to go. So if they're saying 3 times that, we're going to do the opposite and divide both sides by 3. Get them away. Okay, so then you're going to be left with, let me fix my paper. Okay, we're going to be left with x to the 1/3 equals 15 divided by 3, 5. Okay, so we're there. Our job is to get rid of this 1/3 power, right? We got who he's on alone. Now we have to get rid of it. So what we're going to do is we're going to raise both sides of the equation to the reciprocal power. So 1/3, his reciprocal is, flip it over, 3/1. So you're going to raise both sides of the equation to the 3/1 power. So what it does here is it cancels those fractions and you're just left with x. Okay, so now we have 5 to the 3/1 left. But guys, 5 to the 3/1, 3/1 is 3. So that's 5 to the 3rd power. So just ask your calculator, what's 5 to the 3rd power? So parenthesis 5, I like to use parentheses to the, use that little up arrow, the caret button, to the 3rd. There's 5 to the 3rd, hit enter, it's 125. So x needs to be 125 to make this equation true. And you're done. Okay, so we're going to use reciprocal powers to get rid of that exponent. Let's try another example. Okay, so look at this one. Solve for x. So x right now is stuck inside these parentheses, and he's stuck being raised to that power. So our job, if you notice, 2/3, the fractional exponent, is on this entire parenthesis. So our job is to get this entire parenthesis by itself, which means I have to get this +2 away. So move the +2. So -2 to the other side, and you're going to be left with 5x plus 1, all of it, raised to the 2/3 power equals 6 minus 2, 4. Okay, well, since the fractional exponent is on all of this, the only way I'm going to be able to get rid of it and free all of this stuff is to raise it to the reciprocal power. So we're going to raise both sides to the reciprocal power. 2/3, the reciprocal is 3/2. Raise both sides to the 3/2 power. So what it's going to do on this side is cancel it out, and you're going to be left with 5x plus 1. And then that's going to equal. Now, 4 to the 3/2. Either you can take 4, throw him under a radical, and then make it a root and a power like we did in the last section, or just ask your calculator to do this. If you want to know what 4 to the 3/2 power is, I like to use parentheses, parenthesis 4, raise it to the, now I'm going to put the 3/2 in parentheses to keep it all together, 3 divided by 2, and hit close. So that's 4 raised to the 3/2 power, and it will automatically turn it into this for you, and then hit enter, and the answer is 8. So 4 to the 3/2 is 8. And the reason it's 8 is because you're taking the square root of 4, which is 2, and then you're raising it to the 3rd power. 2 to the 3rd, 2 times 2 times 2 is 8. So again, it should be 8, okay? So now, all you have to do is finish solving this for x. X is now free, and you can get to him. So minus 1, like we normally would have. 5x is going to equal 7. Divide by 5, and yes, you can get fractions as answers. X will equal, try to divide or reduce this, but it doesn't, so 7 over 5 is your final answer. X equals 7/5, okay? All right, let's try another one. Again, more practice, the better you're gonna get. All right, so our job is to solve this for x, right? X is stuck inside these parentheses being raised to that power. So we need to get, since 3/4 is on this entire parenthesis, now again, he's not on the negative sign, he's just on the parentheses. So we need to get this completely by itself, right? All right, so I have this negative sign and this positive 1 that have to go away. We always start with the one that's not attached. So minus 1 from both sides, and you're gonna get this negative sign. Think of it as a negative 1 times x plus 2 raised to the 3/4 power equals negative 8. Okay, well, since this is like negative 1 times that, if you want to put a little negative 1 there, then we're going to have to divide it away. So then divide by negative 1 to cancel it out. And now you're going to get x plus 2 raised to the 3/4 power equals positive 8. Okay, now, since we got what the exponent was on alone, now we can raise it to the reciprocal power. So raise both sides to the reciprocal power of, not 3 over 4, 4 over 3. Okay, so they're going to cancel, and you're going to be left with x plus 2. And then either you can rewrite this as throw 8 under a radical, and it'll be the 3rd root to the 4th power. Or ask your calculator, what is 8 to the 4/3? What is 8 to the 4/3 power? So the up arrow gets you an exponent, and then to keep your exponent together, 4 divided by 3, I like to put it in parentheses. 8 to the 4/3 power. Hit enter, and you get 16. And again, the reason it's 16 is because you're taking the 3rd root of 8, which is 2, and then you're raising 2 to the 4th power. 2 times itself 4 times, 2 times 2 times 2 times 2 is 16. All right, and now all you have to do is finish solving for x. So that just requires us to minus 2. And then you're going to find out that x has to be 14 to make this equation true. Okay? All right, couple more, and then you should be good to go on your homework. Okay. All right, look here. Our job is to solve this for x. So, right now, this fractional exponent is on all of this, right? All of this is being raised to the 1/2 power. So I have to get all of this by itself, which means I just have to get the 6 away. So add the 6 to both sides. And you're going to be, if you need me, I'll be done in a minute. All right, so we're going to get 3x plus 1, all raised to the power of 1/2, equals 4 plus 6 is 10. Okay, so all of this is alone now, so now I can use the reciprocal power, 2 over 1. So we're going to raise both sides to the 2 over 1 power, which, yes, is just 2. So essentially, we're squaring both sides, okay? All right, so these are going to cancel, and you're going to be left with 3x plus 1 equals 10 to the 2 over 1, guys. That is literally 10 squared. 10 squared is 100. All right, and now all we have to do is finish solving for x, because now x is free and we can get to him. So minus 1 on both sides, and you're going to get 3x equals 99, and the only thing you have left to do is divide both sides by 3. And then x will equal 33 to make this equation true, okay? All right, perfect. All right, now your homework today is going to be on quizzes, not Delta Math. So I saw a couple of these on quizzes, so I just wanted to go over it with you. So we have been trying to solve equations with these fractional exponents, right? Well, this one looks like a radical, but it's a third root raised to a fourth power. So what they're going to want you to do is turn this back into its fractional exponent, right? Now again, if you wanted to get it by itself, if you wanted to get the radical alone first, you could do that. You could add 10, or you could fix it right now. It's totally up to you. So really what happens is, this is actually, this radical, the way we're going to get rid of it is we're going to have 3x plus 2, right, is being raised, is being third rooted, and it's being raised to the fourth power. So that can go back to the fractional exponent of 4 over 3, right? It's power over root. So the power stays up high and the root becomes the denominator. So now you've turned it back into one of these fractional exponent equations. So again, it's power over root. The power stays up high, the root goes underneath. And then minus 10 equals 6. And now we're back in business and we can use that reciprocal power again. All right, so let's add 10 away because right now 4/3 is only on this. So we want to get that by itself. So add 10 to both sides. What's the matter, bud?
Mom, where's the other one of these?
I don't know. Hold on one second, sweetie. I'm almost done. All right, so 3x plus 2 raised to the 4/3 now has to equal 16. All right, so now that this is by itself, we can raise it to the reciprocal power. So raise both sides to the power of 3 over 4. 3 over 4. Okay, so they cancel, and you're left with 3x plus 2 equals, either turn this into its radical with a root and a power, so it'll be the 16 goes under the radical. It'll be the fourth root raised to the third power. Or just ask your calculator, what's 16 to the 3/4? So 16 to the, oh, sorry, I forgot it. 16 raised to the 3 divided by 4 and hit enter and you get 8. Okay. All right, and again, the fourth root of 16 is 2. 2 to the third power is 8. So that's what we should have gotten. All right, and now all you have to do is solve for x. So minus 2, and you get 3x equals 6. Divide both sides by 3, and x will equal 2. And 2 is your final answer, okay? All right, so that's how we solve these fractional exponent equations. We still raise both sides to a power. You just have to use that reciprocal power to cancel out that fraction. Okay? As always, if you have any questions, please reach out to me. Otherwise, your homework, like I said, is going to be on quizzes, not on Delta Math today. All right? And then we will take a quiz on Thursday on 6.7, solving these types of equations and the equations with those radicals. Okay? All right, good luck on your homework. Let me know if you need help.